Hello everyone, and welcome to the electronics bench here at the Switch List. In keeping with the purpose of my channel, I wanted to put together a video describing how I repaired a Tech 2 Railpower 1400, which is not the unit you see here on the bench. I'll put up a picture, stock photo as they say, of the actual one of the units. I'm not going to show you that unit just yet because I don't want to spoil the surprise. I bought the unit off of eBay for $15, and the auction said it was in working condition. So when the unit showed up, I plugged it into the wall, connected it to the track, put the locomotive on the track, turned it on with the throttle set to 0. The train took off and shot down the rails. So immediately I knew I had a problem. Adjusting the throttle had no effect. So I took it over here on the bench. I put on a digital multimeter to measure the voltage, and sure enough, the throttle, the output was fixed at 14 volts no matter what you did with this. So I immediately said, okay, well, let's take it apart and take a look inside and see what we get. So here's where I ran into problem number one. These things are held together with, I don't know if you can see that, but these are the tamper resistant or tamper proof screws. This is a T8 screw, so you need a special bit. So I did not have any of those bits, and this was about the second or third time I had run into the need for them here in the past few months. Since getting back into the hobby, I've managed to run across a couple things. So I went on to Amazon and I bought me this handy dandy little DeWalt's set of security bits. Has all kinds of different security tamper resistant bits. So I got it. I was all excited. It even came with this little adapter here to put it in your drill motor or some other kind of screwdriver attachment. I flipped it over, took out the T8 bit, which is the one that fits this screw, and I dropped it. Problem number one. The hole is too small for the bit itself. Okay, no problem. I figured all I got to do is just hog those holes out a little bit so I can get the bit down in there, and we'll be good to go. So with that said, I will pull up the actual unit here. So here you can see I went ahead and I did actually drill the holes out, and you can see that this does actually fit down in there. I'm able to get thing, screw that, no problem, right? Then I come to this one, and I'm still able to get these open. But as you can see, this has got a beveled side, so it's where the actual screw is getting farther and farther away from the back. So fortunately, these were not particularly tight, and I was able to. Here's another problem. You see that this is magnetic, so it pulls it back up inside. So I have to get it seated, and then quick get enough tension on it to get it out and unscrew that. Then the final problem was, when I went to drill this piece out, for some reason I was expecting this to be a thick piece of plastic, even though it wasn't any thicker here than it was there. And I put a lot of pressure on, this is the one I did first, on the back side here, and when I put a lot of pressure on it, drill bit went right through instantly and actually ended up tearing up fortunately it's the AC accessory output terminals on the inside. We'll take a look at that when I get it open. So let me pause real quick here. Let me actually take this all apart. We'll take a look at the inside. Okay, I'm back, and I forgot to mention that in the end I didn't even need to go out and buy this drill bit set, because it turns out that if you take a small enough screwdriver, you can actually fit it in there and it'll work against this has a small pin right in the center, which is why the bit itself has to have a hollow tip, and so you can get that in there, get it lodged against that center pin, and actually pull this out, which is how I ended up doing it. Actually ended up getting this apart that way. So now I've got it open, and in between the time while I was waiting to receive these drill bits and try to take this apart, I happened to be having breakfast with my model railroad club one morning, and I mentioned my predicament, what had happened, and somebody made a statement about, oh yeah, the rheostat, or the potentiometer has gone, I think they called it a rheostat, potentiometer has gone bad, and they said it as though it was a very common thing. I'm like, okay, yeah, that makes sense. This variable resistor here, which controls how much voltage is actually making it out to the track terminals, has failed, and it's basically failed to a minimum voltage state, or minimum resistance state, so you're getting maximum voltage out all the time. So when I got this open, first thing I had to do was I went ahead and unsoldered all of these connections, and I tested the variable resistor. And you can see here that as I took everything apart, I put I think black, blue, and red. I marked the letters here so I could remember what color wire was attached where. I did the same thing up here, blue. You can't see it, but here I've got a note, blue, red, white. So I disconnected all the wires, including this capacitor wire, and I checked the variable resistor, and it was fine. So then I was like, well, maybe something's over here, and looks like it's probably a bridge rectifier. This is a very, very simple unit. It's got only power and a direction switch. Doesn't have brake or pulse control or any momentum or any of that. So this is a very simple unit. So anyway, I wanted to take a look at what was going on in here, thinking maybe something had failed on this board. One of the diodes in the bridge was shorted or something. So, of course, this was not designed to ever come out. It's mounted with some like plastic, molded plastic tabs or screws, for lack of a better term, that the switch just fits down over. And I don't know if they had melted it a little bit to make it latch and hold on, but it wasn't a screw held on with a screw. So in the process of trying to get this board out, I ended up having, and in order to get the board out, I ended up having to drill the holes out. Or I think I actually broke it off, and then so in order to be able to remount it, I had to drill holes so that I could put a mounting screw in. So I was taking a look at all of the things here. I couldn't find any problem with that. And then I came to, and I don't know if you can see here, let me see if I can get that out. Looking at it right in here, let me see if you can see here. Boy, that's going to be tough. Oh, here, maybe if I do it like that. Right here you can see, I need better light on this. This right here is the power transistor, which is really where all the magic happens. And that's literally all this unit is, a variable resistor, a diode bridge, a switch, and this power transistor. So I then did some testing, and again, I'm not going to get into the details of how I did all this. This isn't really about how you go about troubleshooting and fixing it. I just wanted to share with you all the trials and tribulations that I went through. So what I ended up doing is doing some basic testing on this. I've discovered that this power transistor had failed, and the output was just shorted to the input voltage, and so that's why you're always getting the 14 volts out. And here's the actual unit that I took out, the actual component. This is a D1192 power transistor, and I don't know if that's a Dallas Semiconductor or who that is, but one of the first things that I had noticed when I opened this up is if you can take a look at, I don't know if you can really see this, the very high quality in which that was used when assembling this unit. These were literally just stuck on. They're just soldered right onto these leads. There's no heat shrink or anything to protect them. They were just all bent away from each other. And when I first got into the hobby in the late 70s, early 80s, MRC, at least in my own mind, was like the gold standard of power packs, right? And I bought one. I did have one, and they weren't all that expensive, but for a kid of 12, 13 years old, it was a lot of money, and I was just like, these are the best things ever. And now to open one up and just come face to face with just what low quality is going into the assembly of these, it was an eye opener. So anyway, I did a quick Google search of D1192 and found out it was a power transistor, no longer available. But what I was able to find was that there was an NTE direct replacement. So it's a NTE 263. It's a NPN Silicon Darlington power amplifier. So I ordered one of these from Wholesale Electronics. I actually ordered two of them, and they were a whopping $2 or $3 a piece, plus $10 shipping. So $15 for the unit itself. And I didn't mention, I contacted the eBay seller, and I told him that it didn't really work, but for $15 with free shipping, I wasn't really all that worried about it. I was going to try to see if I could fix it. So I was in for $15 to get the unit originally, another $15-ish to get the replacement parts. So when they came in, it was just a simple matter, and as I had mentioned, I've labeled down here the blue, the red, and the white to indicate where they were once the transistor's mounted. I went ahead and put some heat shrink on it when I reassembled it. Now, because I had tore up these terminals here, I was like, I don't need the AC anyway, so I just disconnected it. Well, the power coming over into the bridge was actually coming from these. Those wires were soldered to these terminals, which were coming. So the power comes in through the switch into the primary side of the transformer. Then it came out of the secondary side to go over to here to power the AC accessories. And then the wires going into the rectifier were coming from those two terminals. And then the DC came through the resistor into the power amplifier for the Darlington pair, and then ultimately back out to the variable DC. So anyway, what I had to do is I then had to take the wires that were bringing the power over here to these terminals, and I just spliced them directly to the wires that were picking up the AC voltage coming into the bridge rectifier. So you can see that there. So anyway, guys, once I put it all back together, it worked like a champ, and this is just going to be the unit that I use I have a test track over on my other bench where I work on when I do locomotive work or whatever, that I have a track, and this is just what I use to power if it's a DC unit, because I do have a number of DC units. So I got to put this all back together. So anyway, the whole point of this was just again, not to go through how you actually troubleshoot and repair one of these, but just to show you what I went through on my $15 eBay treasure in order to get it to work. And in the end, it wasn't that big of a deal. I did end up screwing this up a little bit. The case, I screwed up the switch mounting here, and unfortunately there's really not a way to get this other screw in. I mean, I probably could if I really wanted to futz with it, but it's just not worth it. The one screw's holding it, and like I said, it's just for on the bench. So, and then I messed this up, and you can see here I did go ahead and I just put a tag on here with a note saying the date that I replaced the blown D1192 with an NTE 263. So anyway, guys, I hope that was amusing, and it was certainly not amusing while I was going through it, but I thought I would share that with you to keep in line with my goal of sharing you my victories and my defeats and the trials and tribulations of my model railroad journey. So thanks for watching, guys. Hit like, leave comments, subscribe, whatever you want to do. So I appreciate it, and I will look for all of you down the rails. Take care.